Okay, the light was getting poor during that last recording, so I figured I would take another crack at this video. So this section is on useful ways to make starting materials for the palladium couplings. You want very often sp2 halides and things like that in order to do couplings. You also need sp2 carbons bonded to metals like boron in the case of the Suzuki reaction, tin in the case of the Stille reaction, and also zinc in the case of the Negishi reaction. These are the pages in the book. You'll find them. So there are four things I wanted to talk about. The first two are on the vinyl halide side. A lot of these couplings involve a vinyl halide. So a vinyl triflate is not a halide, but it is a good leaving group. And you can make a vinyl triflate very nicely from a ketone by forming the enolate and then taking it over here. Let me just make sure this is visible. And remember the trifle group, it's a CF3SO2 group. And use this ditrifle aniline is what it's sometimes called, phenyl ditriflamide. This vinyl triflate will act in a coupling reaction rather like a vinyl iodide. In fact, it will also couple with organocuprates in the same kind of way. So it really is a good substitute, and ketones are a lot easier to come by than the starting material for something like that. So that's on page 339. There's another way to make this kind of compound where you actually put a real iodine on, and that's to use organochromium chemistry. So if you see page 299 in the book, this method gives you an E vinyl iodide, and what you do is you start with an E vinyl iodide. Start with an aldehyde and couple it with iodoform in the presence of chromium 2 chloride. Now, this is obviously readily available. You know how to make aldehydes, things like PCC or Swern, right? Iodoform is quite readily available. It's made, in fact, just by adding iodine to something like ethanol or acetone, anything that has an oxidizable CH3 next to potentially acetyl bond O. So you add iodine to those in the presence of sodium hydroxide and you get what's called the iodoform reaction. Chloroform can be made in the same way using chlorine. So this is cheap, readily available. It actually precipitates out from that preparation as a sort of pale yellow solid. It's very easy to make. Chromium 2 chloride, on the other hand, is not so easy to make. Chromium 2 is not the stable oxidation state for chromium. So this is often made from chromium 3, sometimes in situ by adding chromium 3 chloride to something like lithium aluminum hydride, like that. So you do the reaction in the presence of lithium aluminum hydride. You get a vinyl iodide like this, and notice that you've added a carbon. So if you're counting the carbons in your synthesis and you find you've got an extra one that you need to add in, this is probably what I had in mind in the homework question.
Oh, hi, how are you? I'm sorry.
And also, I'd like to talk about a couple of ways to make vinyl boranes and vinyl tin compounds. So this is the other part of the coupling, where you have the C double bond C bonded to a metal. So for vinyl boranes and vinyl stannanes, the best way to make them is by hydroboration or hydrostanylation of alkynes. And with boron, we've seen 9BBN being used. We've seen in CHEM444 II, I think we used dicyamal borane. Here's another one for you, catechol borane. It's a little more stable because it's no longer, these aren't R groups, it's actually oxygens. And this makes, in fact, the boron a little more stable. Catechol borane can easily be made. And there are other similar compounds like this. Pinacol borane is another. Now these are a little less reactive than BH3 would be towards alkynes, but it can still be persuaded to react, and you get something like this, where the boron and the hydrogen have added to the same side, which means the B is now trans to the R group. The tin hydrostanylation goes in a similar way. We just use tributyl tin hydride, tributyl stannane, and that gives us initially the Z isomer, and if you heat it, it gives you the E. And we covered this chemistry when we did the preparation of those organometallics, but I wanted to cover it again now that we're doing the palladium chemistry, because these are popular ways to make those compounds. I'd like to mention as well that alkenes are also a good starting material to use with hydroboration, because the alkyl boranes, say a catechol borane with an R group on it, things like that are useful for the Suzuki coupling as well. So it's not just sp2 carbon boron compounds that we want. sp3 carbon boron compounds are also useful for the Suzuki coupling. Stille, on the other hand, is pretty much limited to sp2 carbon compounds.